Undoubtedly, the macrocosm surrounding us presents the greatest number of mysteries. It is not easy to solve them, but nothing prevents us from developing a series of hypotheses, more or less close to the truth. You will agree that to this day, despite the knowledge and technology at our disposal, some questions remain difficult to answer. For example, how big is the universe and does it have boundaries? Progress does not stand still, so soon our comprehension will be significantly enhanced, because a new generation of telescopes are coming into action, confidently opening the doors to the vague past of the vast universe. More recently, people have been able to view the world in ways that go beyond the capabilities of the orbiting Hubble. 2 years later, the world's most powerful infrared observatory, called the James Webb Telescope, went into operation. Thanks to this unit placed into orbit, we are able to find exoplanets, observe the formation of galaxies and the birth of stars. Additionally, HabEx is being prepared for launch. It is designed to search for super-Earths and can block out the bright light of stars. The X-ray Lynx is also being developed, with ultra-sensitive detectors to identify locations where black holes form, and the OST, with a huge 9-meter mirror and hardware 30 times more sensitive than James Webb's. Thanks to recent technological advances, we can now examine Proxima b, which is located near the star Proxima Centauri, 4 light-years away, as well as Kepler 16b, the prototype of the legendary Tatooine. Moreover, astronomers will be able to see the Satan's eerie lair, the Coro T7b, a planet with a hemisphere that is constantly raining rock. But let's think about another interesting question. How can a person who is used to the pygmy scale of Earth understand, let alone measure, billions of universal kilometers? It is extremely difficult for Earth inhabitants to imagine the location of the aforementioned planets, where life may exist, and their distance from us. So let's have a little enlightenment. What units are commonly used to measure distance in space? Within our solar system, it's done in astronomical units. An astronomical unit is equivalent to the average distance between the Earth and the Sun, which is 150 million kilometers. However, once outside the star system, it becomes extremely inconvenient for scientists to count dozens of zeros, so such a unit of measurement as the light year comes into play. It includes the distance a photon of light travels in 365 days. With a little rounding, the speed of light would be 300,000 kilometers per second. The result is a huge number with 12 zeros. Given this information, it's scary to think how far away from us is, for example, Proxima b, one of the closest exoplanets found. This information is able to activate the imagination, but a clear realization of the scale of the mentioned distances has not come. So let's try to measure the annual path of light in the usual equivalent human steps. It sounds strange, but try to abstract and visualize what we will talk about next. For example, by performing basic calculations, you can determine the following. If a person moves continuously at a speed of 5 kilometers per hour for a year, he will cover a distance of 43,800 kilometers. Now, let's take the average life expectancy of 68 years and multiply it by the above figure. We get 2,078,400 kilometers. That is, if you walk your whole life without stopping, you will have traveled only about 9 light seconds. Think about it. Man will not even reach Mars. But, as you know, one is not a warrior in the field, so let's calculate how many kilometers the Earth's population will travel, dividing into pairs and alternately every 68 years, passing the baton to the next tandems. The figure is much more tangible: 11,319,371,410, 6,800 kilometers. As you can see, that's even more than a light year, but it would take the entire planet millions of years to walk. Now think about how many people and time it would take to walk to, say, Alpha Centauri b, which is 4.4 light-years away. And if you try to cross the Milky Way, which is 100,000 light-years across, does it make your hair stand on end? Then don't even bother trying to calculate the man-hours required to pilgrimage through the largest known galaxy with a diameter of 6 million light-years, we can say for sure. The efforts of all the people who have ever lived on Earth, which is about 107 billion people, are not enough. If the distances to individual members of the stellar planetary brotherhood are so enormous, how enormous is the universe itself? No one living on Earth is able to say exactly what its dimensions are and whether the macrocosm is finite. But one indisputable fact is known. The sky, which we look at every night, is a kind of video recording. In other words, an excursion into the past. The only question is the time. Sometimes it is only 8 minutes, as in the case of the sun, and sometimes it is millions and billions of light years. That is, that shining point you are looking at now may be a galaxy that died many centuries ago, but the light from it will be traveling along the universal paths for a long time to come. For dessert, let's raise one more actual problem of cosmology. Behind what line of macrocosm we cannot look, and what objects we can observe relatively unobstructed. It's known that the boundary of the observable universe is about 45 billion light-years away from us. That's an incredible amount of light-years away. But what lies beyond that horizon? It seems that mankind will not open the veil of this mystery for a long time. By the way, it is worth mentioning the hypothesis of stable expansion of the universe, often discussed in scientific circles. It is accepted that it happens evenly in all points at once. So it is impossible to understand where you are now, in the center or on the periphery. So the horizon could be moving away over time. And then it is unlikely that even in thousands of centuries there will be telescopes capable of looking beyond the invisible boundary of the titanic bubble and see what is hidden in the inky darkness of the cosmos. And of the optics that exist today, neither Hubble, James Webb, OST, nor Lynx are capable of doing so. Fortunately, there are so many interesting objects around us that will take generations of astronomers to study that it's very tempting but unproductive to think about the boundaries of the universe. If you are interested in this topic, then write in the comments your variant. Perhaps you adhere to the version of multiverse with alternative laws, or believe in a boundless and flat macrocosm. Or maybe you are a follower of the hypothesis that mankind lives inside a huge black hole. By the way, if you dig in the playlists of our channel, you can find a video about it. Be inquisitive, put likes, share content with your friends, suggest fresh, interesting topics.